viewers, welcome to this video lecture series on C programming. Today's topic of discussion is on constants. Constants in C refer to fixed values that do not change during the execution of a program. It means that whatever value you are assigning to a constant, it is going to remain same throughout its execution. And also this constant, it cannot be placed on the left side of the assignment operator because it does not have a modifiable value. It can only be placed on the right side of the assignment operator. For example, see how we are going to declare a constant. We'll use the keyword const, and suppose if the data type of that constant is integer and you are just using a variable term equal to 10. So this means what? The value for the term is assigned as 10 and it remains same throughout the execution. It is not going to change. Now wherever this variable term appears in the program always takes the value 10 for this particular variable term. This is the assignment operator and you are going to place the value here 10, which is on the right side of this assignment operator. Now constants are classified into two major categories. First one is the numeric constants and the second one is the character constants. Further, numeric constants are classified into two types: integer constants and real constants. Let us see what do you mean by numeric constants. Numeric constants can further be divided into two types: integer constants and real constants. What is an integer constant? It refers to a sequence of digits. There are three types here in integer constant. First one is the decimal, second one is the octal, and third one is what? Hexadecimal. These, how are you going to write the decimal constants? It consists of first of all digits from 0 to 9. And it can be preceded by an optional plus operator or minus operator. For example, suppose I'll give you few examples for the decimal integer constants. You can write down 178. This is an integer constant. You can write down minus 785. This is a integer constant. You can write a bigger number also, 65431. You can write down with plus 68. So these are the different examples for the decimal integer constants. So what is that you have observed? First thing is, an integer constant must have at least one digit. Here must have at least one digit, okay. And second point is, it should not have any decimal point here. You can observe in all these examples, for all decimal integer constants, you are not going to use what? The decimal point. You cannot write 0.5, okay. This is not a valid decimal integer constant. Whereas this can be there, this is also a valid because it can be preceded by a minus sign, and this is valid, it can be preceded by a plus sign. Minus indicates a negative value and plus indicates a positive. So if you're not using plus or minus, suppose if it is like 621, even then it is considered as positive. So you cannot use special characters here. You cannot use blank spaces. For example, you cannot write 17-9. This is not a valid decimal integer constant. You cannot give a space here like 7 space 5. This is also not a valid decimal integer constant. So this is valid, this is valid. So these are the few examples for the decimal integer constants. If an integer constant starts with a 0, then it is an octal number. For example, I can write down 0, 2, 3. Now this number is preceded with what? 0. It becomes an octal number. The decimal equivalent for this 23 is what? 19. 0, 4, 3, 2 is an octal number. 0, 5, 5 is an octal number. Fine, just one single 0 is also an octal number. An octal integer constant actually consists of any combination of digits from 0 to 7. The third type of the integer constant is hexadecimal. If an integer constant starts with 0 followed by x, either it can be 0 uppercase x or lowercase x, then it becomes a valid hexadecimal integer constant. For example, if I write like this 0x23, it is a valid hexadecimal integer constant. It means what? 23 is in number system and 0x23 is a valid hexadecimal, which means 23 is an hexadecimal number system and its equivalent value is how much in decimal? It is 25. Then what about the sequence of digits that are used? What are the different digits that can be used in the hexadecimal? In the hexadecimal integer constants, you can use the digits from 0 to 15 and the letters A to F. For example, hexadecimal numbers as 0x3. This is a valid hexadecimal. Okay. Then 0x3 to F. I can use it because it is what we are allowed to use this particular letters from A to F. Then I can use just 0x9b. This is also a valid hexadecimal integer constant. So the same rule is applicable even for the octal and decimal. You cannot make use of any special characters, cannot make use of the underscore, you cannot make use of the blank space. Space is not allowed, it is not a valid hexadecimal integer constant. So these are the different examples which I have mentioned here for the integer constants. Then we have the second category as the real constants. So, and these real constants are also called as floating point constants or the floating point numbers. So I'll give few examples here for the real constants. Like suppose if I'm writing 0.0075, this is a valid real constant and I can use a minus sign. First and foremost rule is what? Real numbers are what? Having the decimal point included. It's not that always all the floating numbers will begin with 0. This is also a valid real constant. You can put the decimal point here. Then you can use the plus symbol also. Fine. These are the different examples. You can omit the zeros after the decimal point. Like for example, you can write down 216 point. Okay, here 0 is not mandatory. You can omit that 0, or you can omit a 0 before the decimal point also. This is also a valid real constant. You can write even like this. Fine. So real constants will have definitely the decimal point included, but the 0 which is going to appear after the decimal point or before the decimal point can be omitted. We have one more way of representing the real constant, and that the general form of this is mantissa E exponent. You are using the letter here E. E can be used in lowercase or E can be used in uppercase. So this form of representation, so that means what? The real constant can be represented with either these notations. Fine. And these notations are called, you can say that you are representing this in fractional form, and you can also represent in this form mantissa E exponential, and we call this particular form as the exponential form. Mantissa E is either a real number expressed in decimal notation or an integer. The exponent part is an integer number with an optional plus or minus sign. This notation is also called as floating point form. Remember the two names here. One is the exponential form and the other one is what? The floating point form. Let me give few examples for this form. Like I'll tell you, you can write down 0.78 E followed by 4. Then I can write 16 E. I can use a minus sign here. Then I can use 1.8 E plus 8. I can use 3.27 E followed by some digit I'll write. Then this is also valid, or I can use here also minus. Okay, that means I can use here one more example. Let me write minus 1.2. I have given all possible types of examples. What exactly I mean to say here is the mantissa part, if you see, should have the decimal point or may not have the decimal point. So in this example you can see 0.78, 16 directly I am writing without any decimal. Even this is allowed. 1.8, it has got decimal point. Minus 1.2 you can use. Okay, it has got a decimal point. 3.27 you can use, it has got a. That means the mantissa part may or may not have the decimal point, whereas the exponential part should not have the decimal point only. The rules are the mantissa can either be positive or negative. The default sign is what? Positive. The mantissa part should have at least one digit. So this is the mantissa part. Mantissa part can have a decimal point, but it is not mandatory. That's the reason I have given one example here, 16E minus 2. It is not mandatory that you include a decimal point always in the mantissa part. The exponent part must have at least one digit. Look here, E4, E minus 2. The exponent part cannot have a decimal point. This thing you have to remember. You are not going to write anything like this 16E 4.3. That means you are including a decimal point here in the exponent part, which is not allowed. So this is not a valid real constant. No special characters are allowed, no blank spaces are allowed here. The mantissa part may or may not have a decimal point. The exponent part cannot have a decimal point. Now coming to the second main category here, that is the character constants. So for character constants, it is further divided into two main categories. The first one is the single character constant, and the second type is the string constants. And the examples for the single character constants, any alphabet that is written in single quote becomes a character constant. Even the digits or a special character or even a blank space, it will print actually what the ASCII value of this. Suppose if you are using in the printf statement this single character constant, it will print what the ASCII value of this. The ASCII value of A is what? 97. Set of characters which are enclosed in double quotes becomes the string constants. Here in string constants you can give a space between two words also. Good day, I can use like this, or I can use even simply the digits 1, 2, 3. This is also a valid string constant. Okay, or I can make use of one single character here. Okay, suppose if I am writing the letter T, you cannot call this as a single character here because now it is enclosed in double quotes. It becomes a string constant. One important point you need to remember for this string constant is each string constant is implicitly terminated by a null character, that is backslash followed by 0. It is terminated with a null character. Suppose if this is the string constant, implicitly it is getting terminated with a null character here. Now it means what? Here 1, 2, 3, 4, 5. 5 characters are there. Each character will occupy what? 1 byte, let us say. Now if there are 5 letters, that means it is going to occupy 5 bytes plus 1 byte for what? Plus 1 byte for the null character. So that means the total space that gets occupied in the memory here is 6 bytes. Though you can see that the length of the string is what? The length of the string is 5. When you want to determine the length of the string becomes only 5. Whereas it is taking 6 bytes in the memory. That is because by default every string constant will get terminated with a null character. You have a string constant ABC. The length of the string is how much? 3. Whereas the bytes, how many bytes it occupies in the memory? 4 bytes. The reason is what? The reason is 3 bytes are for these 3 letters plus 1 byte is for the null character. So this is how you have to remember that for the string constant, always the string constants gets terminated with a null character. Apart from the integer constants and character constants, you must also get familiar with one more type called as the symbolic constants. Symbolic constants are created with the help of define preprocessor directive. And how are you going to use it? You'll use this particular symbol hash followed by this preprocessor directive called as define. Then you write here the variable name. Suppose if you are using the variable term and then the value constant. So this type of declaration you are carrying out before the main function. So this is also a symbolic constant. This is a type of a symbolic constant. It will take the value 10 for the variable term. So in the entire program, wherever the variable term appears, it substitutes the value as 10 here. It is making use of what here? The difference is it is making use of the define preprocessor directive. Now we have few more constants which does not get printed but action is performed. So in the printf statement, whenever you are using such type of constants, we call it as non-printable character constants. We always use the escape sequences here for the non-printable, and the escape sequence consists of a backslash followed by a character, and both will be enclosed within single quote. Suppose if I am using an escape sequence like backslash followed by T, then this backslash and T will be enclosed with a single quote. An escape sequence is treated as a single character. The following are the escape sequences. You want to print a single quote. It is getting enclosed here because this is the format. You need to enclose the escape sequence with a single quote. Then you want to print a double quote like this. Fine. So double quotation mark can be printed. You want to print a question mark, write like this. You want to print a backslash character only, then you have to write like this. So this is the backslash initially, and this one is what you want to print the backslash. Then you want to get an alert by generating a beep. For that the escape sequence used is A. Okay. You want to move the cursor one position to the left of the current position, then you have to use this one. So we call it as backspace here. This most of you must be familiar. Backspace, this is what, this is an alert. Then you can use letter F here. It is called as form feed. What is its action? It moves the cursor to the beginning of the next page. /n, new line. It moves the cursor to the beginning of the next line. We have /r. It is called as the carriage return. It moves the cursor to the beginning of the current line. Then we have the /t. It is called as the horizontal tab. What is its function? It moves the cursor to the next horizontal tab stop. Then we have /v, which is the vertical tab. Then we have the /0, which is a null character. What does it do? It prints nothing. Finally, you can say that though we started with the two major categories, constants, but remember, you can even include the other two, which is what? Symbolic constants. This is what I explained. The main two categories: integer constants, character constants, non-printable character constants. This is all about the constants in this session. If you find this session useful, please like, share and subscribe to my channel Engineering Wing. Thank you. Bye bye and take care.